All right, students, this is Mr. Morris coming back to you. It is, March the 30th, I think, of 2020. So we're moving right along. It'll be April before you know it. If you haven't got a chance to yet, you should have. So poo on you if you didn't, but I'll forgive. Go back and watch last week's video on how to solve by factoring and how to solve by quadratic formula, because those are big concepts that you need to have a grasp of. All right, so what we're going to do today is do another review of quadratic formula and also look at something new, slightly new but not too bad, called the discriminant, not discriminate, okay, discriminant. It's a math term. All right, so take a look here. I have a funny looking quadratic function right here that isn't as scary as it might appear to you. All right, I want you to pay attention to this, y'all, because just because x squared is on the left side of the equal sign and negative 3x plus 40 is on the right side doesn't mean that you don't have enough to play ball. The first thing we need to do is always get everybody on one side of the equal sign. Right now, x squared is all by his lonesome. You could easily move these two guys over, or you can move him over. For this example, I highly suggest not moving x squared over, but moving the other two terms, because I like my leading coefficient to be positive, not negative. If I were to move the x squared over to the right, it'd become negative x squared, and that's not as much fun. So I'm going to move both the negative 3x and the positive 40 to the left-hand side, and we do that by inverse operations. Add 3x to both sides. That gives me x squared plus 3x equals 40, right? And now we got to move the 40 over too, so I'm going to minus 40 on both sides. Also, that gets rid of the 40 there, makes it 0, which is what I want. And we're left with x squared plus 3x minus 40. Please do this along with me. Feel free to pause the video if you need to, so that you can understand, and we'll go at your pace. Okay? That's the cool thing about video. All right, so this now looks like a quadratic trinomial function, one that we are ready to solve. You can try to solve it via factoring, but that could be kind of difficult. You're going to have to really think about, okay, what multiplies the negative 40 and adds to 3? You might be able to do that. I don't know. But guess what always works? Quadratic formula. So I'm going to do quadratic formula mainly because I want to just practice that. So Matthew, I know you watched some kind of weird videos there that you shared on the Facebook page about the quadratic formula song. I hope you remember the formula after all that. But anyway, my version is negative b. Oh, not that. Let's try again. Whoop, I need to watch that video again. Negative b plus or minus the square root of b squared minus 4ac all over 2a. We used to do the kind of kid song, negative b plus or minus the square root of b squared minus 4ac all over 2a. If that helps you, then here's a gift for you. All right, negative b plus or minus square root of b squared minus 4ac. That's quadratic formula. Why do we need the quadratic formula? Because it always works. It always helps you figure out what the solutions are to a quadratic function. Yes, you could factor it sometimes. Sometimes these can't be factored. Yes, you could graph it, but that's kind of hard. Unless you have straight edges, sometimes you're not going to be accurate. But this always works. That's why we like it so much. So I'm going to do a little test run to see if you guys remember last week, and also for practice. And then we'll get into the discriminant afterwards, okay? So this is the quadratic formula. Both Algebra 1 and 2 need to cover this standard. This is going to show up in both lessons, so really in both courses. So it's a big idea. So look, your coefficients are, of course, the numbers a, b, c in the trinomial. So if you look at this formula and plug it in, it's negative b, right? Well, the b term is this 3 right here. In fact, if you need me to write it real small underneath, I'll do it so you don't get confused. The b is 3, so negative b would be negative, let's see, negative 3 plus or minus the square root, and we're going to redo the square root of b squared. So once again, I got to put 3 in there because that's the b, minus 4. The 4 is from the formula, right? See the 4 in there? It's not from the function, it's from the formula. So I have to keep it Nice and lined up. AC, once again, well, the A is 1, I should say. The C was negative 40. Watch your signs and don't go so quickly that you make a silly mistake and get the whole thing wrong because you're not, including the negative 40 when you substitute it in, all right? So just slow down enough to make sure, Tyler, you don't miss these details. Okay, so 2A, boom. I have now substituted each coefficient into the quadratic formula, and now I'm going to attempt to solve. Should get 2 answers, or at least 1 answer that repeats 2 times. So I always start inside out. I look underneath that radical, and I start with the b squared minus 4ac. All right, b squared minus 4ac first, and so I'll do 3 squared. That's really 9. Now what I like to do the 4 times 1 times the c, all this together, and I'll just bring down the subtraction. That's what I like to do, but you can do it different ways. 4 times 1 is 4, and 4 times negative 40 is negative 160. So check this out for a second. See how you have a double negative? This answer equals negative 160, but there's a minus, from the formula itself. So just be very careful about these signs. Sometimes that gets kids. All right, all over 2A. All right, so here's where we are. I took 3 squared, made it 9, and multiplied this one straight across. Boomity boom. You with me? Now remember, what happens when you have double negatives? Mr. Morris, you have to make it a positive. That's right, kid. That's really 9 minus a negative. Well, double negatives is really a plus. So that's really saying 9 plus 160. And 9 plus 160 is 169. Let's bring down what I got left. 2 times 1 is 2, so I'm just going to write it that way. Okay? All right. And then it's time to just evaluate. This just so happens to be a special type of number, all right? Remember, especially my Algebra 2 kids, I said, hey, Ellie, this is your Taylor Swift. Michael, this is your Roblox. Tyler, this is your donut, right? This stands out to you. This number is a perfect square. This is just get your attention. As soon as, Nicholas, what did I say? Oh, the Chili's Texas cheese fries, I believe. Okay, Ashton, this is your Marvel comics, okay? This should just stand out to you. When you see this, your eyes just lock in, right? The square root of 169 is in fact 13. Boom. Now we're almost home, because now that that's a nice, pretty, perfect square, since I can take the square root of it nice and pretty, it's easily 13. You can add it once, divide by 2, subtract it once, divide by 2. Negative 3 plus 13 is 10. And 10 divided by 2 equals 5. There's one answer. But, negative 3 minus 13 is also something we have to do. And that's going to be negative 16, which equals a negative 8. Okay? So we got 2 answers. X equals 5, X equals negative 8. Now check this out. 5 and negative 8. I don't care if you write it like that. Okay? 2 answers with quadratics. Boomity boom. Quadratic formula always works. Oh, Mr. Morris, that's a lot of work. Well, it's a little more work than you might be used to, but when you're walking, it seems really difficult when you're a toddler, and when you get a little older, you're like, wait a minute, I don't even have to think about it. It just comes naturally. See, that's what's happening, kids. Now, just because I don't want to let a learning opportunity blow by, did you know that we could have found out that x was 5 and x was negative 8 a whole lot easier than using the quadratic formula? Mr. Morris, then why did you make me do the formula? Well, A,